So hi all, welcome back to the channel, and in this video we'll be talking about abstraction. So we saw the concept of abstraction several times in our earlier videos, like we saw it in inheritance, right? So but let's go over the concept of abstraction one last time, and then in the next video we'll be covering the class relationships, right? So what does abstraction say? So it says abstraction is the concept of hiding complex implementation details and showing only the essential features of an object, right? So this is very important. So we are hiding the complex implementation details, right? So we don't show the implementation details, but we only show the essential features of an object. Okay, so it helps to reduce the complexity and increase efficiency by allowing users to interact with objects at a higher level without worrying about the internal implementation. So this is also an important point. So it helps to reduce the complexity and increase efficiency by allowing the users to interact with objects at a higher level, right? So we'll see all of this with an example if this definition is confusing. So we'll see with an example and then we'll go back to the definition, right? So if you see in Python, abstract classes are defined using ABC. So let's see an example in Python and then Java, and then let's come back to the definition, right? So this is a basic abstract class. So if you see, we are importing ABC from ABC abstract class, and then we have abstract methods, right? So we have a class shape, and then it inherits, this ABC abstract class that we have defined, right? So this is abstract base class, and then we have two abstract methods defined here, right? And then there is one describe method. This is kind of a concrete method, right? And then this returns a simple print statement, right? If you see, because these are abstract methods, we did not implement them, but whatever is the concrete class that implements this abstract class, they have to implement these methods, right? So we saw this several times in several examples, right? We saw this in polymorphism, we saw this in inheritance also, right? So the same thing here. So here if you see, we have a class rectangle, right? And then this extends from the shape class that we defined earlier. And then here if you see, the area and perimeter, right? So these two methods are implemented here, but in the earlier class they are not implemented, they are just abstract methods, right? So the implementation of these methods that are defined in the parent class have to be implemented in the child class, right? The concrete implementations have to be there here. Same thing goes for circle, right? So you should have the concrete implementations here, right? So one thing is, you can't instantiate abstract class, so you can't do shape is equal to shape, right? So you can't instantiate abstract class, you can only instantiate this concrete implementation classes. So here if you see, rectangle is equal to rectangle, and then you can do area and then describe, etc., right? So what are we doing? What is the use of this abstraction, right? So if you go back to the definition, right, abstraction is the concept of hiding complex implementation details, right? So we are not you know exposing the implementation details, right? We are just enforcing that anything that is a shape should have area and perimeter defined, right? And the second thing is, it helps to reduce complexity and increase efficiency by allowing users to interact with objects at a higher level, right? Without worrying about the internal implementation. So they don't need to worry about the implementation of this, right? They'll be interacting with the high level objects, right? So this is the concept of abstraction. Let's see the same example in Java. So I'm purposely keeping the explanation light because we saw this numerous times in our earlier examples. But if you want to go in depth, just read this article once again, copy the code snippets in your ID of your choice, and then run it, right? So yeah, here in Java you have a class shape, right? So you are defining these two methods, and then you are saying that explicitly that these two are abstract methods, and then you have a concrete method, right? So whatever the class that is extending the shape class, okay, so you see here you are overriding the methods that you defined earlier, right? Same thing for the class circle. we are overriding here, right? So now in the main, you can create an instance of a class rectangle, and then you can call area.describe, and then rectangle.area, and then rectangle.describe. Okay, so that's all for here, and then let's move on to the one more example, right? Payment processing. Let's switch to Python first. So you have a payment processor. This is an abstract class, and then you have these two abstract methods, right? And then there is one concrete method called as validate payment. Now whatever the classes which are extending this payment processor have to implement these two abstract methods, right? So we don't implement the abstract methods, they just provide kind of a definition or a schema for these abstract methods. Implementation details will not be there, but remember, what are the child classes that are extending the abstract class, they should have the concrete implementation, right? Same thing here. So if you see here, the advantage that we get is, so you have three classes, right? Credit card processor, PayPal processor, and then credit card and PayPal, both of them are extending from payment processor, right? So now here, if you see this example, so you have a checkout method that accepts processor which is of type payment processor, right? So that is this abstract class. So it accepts anything that is of type payment processor. Now think, you can pass credit card processor or you can pass PayPal processor, right? Because both of these classes are of type payment processor, right? So that's the reason we can pass either of these processors, right? So if you see usage, like abstraction allows treating all processors the same way, right? So processor should be of payment processor, right? And then you are doing processor.processor process payment, etc. So if you see, you are creating an instance of a credit card, you are creating an instance of a PayPal, and then you can call this checkout method with credit card or PayPal, right? Because both of them are extending from a payment processor abstract class, right? So you can use them interchangeably, right? So function works with any payment processor implementation. Same thing if you switch to Java, right? So same example, exactly same. You have an abstract class, you have these two abstract methods, process payment and refund, both must be implemented. And then there is this concrete method with implementation already there, right? So you have two concrete classes, credit card processor and then PayPal processor. Both of them are extending from a payment processor, right? So both of them are of same type. And then finally you have this checkout which accepts processor which is of type payment processor. So now we can pass instance of a credit card or you can pass instance of a PayPal, right? So if you see, payment processor credit card is equal to new credit card processor, right? So this is exactly what we saw in definition, right? If you see here, go back to the definition. So it says it helps reduce complexity and increase efficiency by allowing users to interact with objects at a higher level without worrying about the internal implementation, right? So see this, underline this, users to interact with objects at a higher level. So go back to the example. See, you are interacting with objects at a higher level, right? So you're interacting with payment processor, you are interacting with a payment processor here, right? So you are not worrying about the implementation details. Because this credit card processor and PayPal processor extending from payment processor, it is for sure that they will have a process payment inside it, right? So you don't need to worry about whether they have this method or not. They for sure have to have this method, so you don't need to worry about the internal implementation of these classes. You can easily make use of the process payment method. Now to the abstract properties, right? So you can also define something called as an abstract property. So switch to Python, and then if you see here, we have abstract class, and then this is an abstract method, and then you are annotating with property, right? Same thing for this method, you are annotating it with property, right? So now we have two classes, dog and then cat, right? So both these things are extending from animal class, right? So because they're extending, they have to have implementations of name and the sound method, right? You have implementation of name and sound. So you also annotated here with @property. So what's the use of these properties? So here if you see, we are doing something like dog dot So when you do dog make sound, it says this buddy says oof, right? But what are the use of these properties? So you can do something like dog, right? So whenever you create instance of a class dog, you can do something like dog dot sound, right? You can directly do dog dot name. So you don't need to do something like dog dot name and then this parenthesis, etc. Because these are defined as a properties. When you do just dog dot sound, that's all you'll get this thing, right? So that's all about abstract properties. Now one thing to note is Java does not have concept of abstract properties. You have to use abstract methods, right? So that's all on abstract properties. So finally, what are all the benefits of abstraction that we saw so far, right? So this simplifies the complexity, right? We saw this, users don't need to understand the underlying implementation details. This makes sure to enforce interface, right? So ensures all subclasses implement required methods, right? So whatever abstract methods that you define on a parent class, you don't need to worry that if the child classes are implementing it or not, right? So they for sure will implement it. Third thing is flexibility. You can swap implementations. So you saw this in this example where finally in the checkout processor, right? So you can pass credit card processor or PayPal processor, right? Why? Because both of them are of same payment processor type. And then finally maintainability, right? So changes to implementation does not affect the interface, right? So if you want to do any change to the implementation, the interface stays the same, only the child classes which are extending they change. Code reuse, right? So common functionality can be shared in the abstract class. This is the main plus point. Whatever the common functionality that you have, you can place it here. If you see for both credit card processor or PayPal processor, validate amount is the same thing, right? So the logic is same, so you don't need to define it again and again. So if you define it in the abstract class, so this concept can be reused. And then finally one last example, database abstraction. Simple thing, you have a class database and then you have all these methods, right? Connect, execute, query, close, enter, exit, all these things, right? So and then let's say if your application wants to connect to two different database, right? So all these concrete implementations, they extend from the base implementation, right? So because they are extending, for sure you are bound to have these methods implemented, connect, execute, query, all these things, because these are abstract methods, right? So they are for sure will be presenting in the child class. And then you can this code works with any database implementation, right? Because it is a type of database. So exact same as how we saw the payment processor example, but this is another scenario where let's say if your application needs to connect to two different databases, so you'll have that generic implementation or the structure to be precise in the abstract class, and all the implementation details go to the child classes, right? So that's all for this video. I hope you have understood the oops refresher module. In the next video, this will be a new module where we'll be talking about all about class diagrams. We'll talk about the relationship between the classes. How should you know present a class visually, like how do you draw those diagrams, what are all the relations between the classes and all this stuff. That will be in one video for class relationships. Once that is done, we are done with the foundations. We'll jump to the design principles and design patterns, right? So that's all for this video. We'll meet again in the next video. Thank you.